Hello everyone, myself Shivam Krishna from Group 2 and our topic of data science project is time series analysis of household power consumption across globe. This project will be able to answer how energy requirement changes over time across geography. So the very first task of this project is data collection. Our data includes the record of electrical consumption for a single household over 4 years. Every minute observation of power consumption within the household from December 2006 to November 2010 has been included in that. It has 7 variables measured for different date and time. First one is global active power representing active power consumed by the household. Then global reactive power measuring the reactive power consumed in the household. Commonly speaking, the active energy is the real power consumed by the household, whereas the reactive power is the unused power in the lines. Then voltage, representing the average voltage measured in the volts. Then global intensity, representing the average current intensity measured in amperes. Here in our dataset, we have three submetrics which records the power consumption of different part of the house. Starting from submetering 1 which measures the energy consumption from kitchen, then submetering 2 from laundry, and then 3 from climate control system such as AC, cooler and geyser etc. This is how our dataset looks, representing each variables in columns and every minute records in rows. Now my team member Rahul will explain you all about the data pre-processing and cleaning.
Thanks, Shivam. For our project, we first had to process our raw data. Initially in the data, we had some missing data values represented with question marks. We marked all missing data values with an N value. As Shivam explained, our data included three submetering values, but some of these values fall short of the total active power. So we introduce a new variable submetering for which is equal to sum of all three submetering values subtracted from total global active power. For this process, we first converted global active power to watt hours and then subtracted sum of submetering 1, 2 and 3. Also, the data we got from the internet was in the form of .txt format and the data columns are separated by semicolon. So we specified the separate between columns as a semicolon. Finally, we changed the .txt file to a .csv file. Also, we merged the date column and the time column to form a single date time column. So after processing, the final data looks like this. As you can see, date time is now a single variable and also it has another variable submitting for. Now our task was data visualization and now Nishant will explain you about this.
Thanks, Rahul. Now, as a data scientist, it is very important to visualize and understand the data. We use different types of graph to look for pattern in our dataset over time, which were mainly line graph and histogram. Now talking about line graph, we plotted different graph for different interval of time. First of all, we created a separate line plot for each of the variable. From the graph, we can see a downward trend in submetering 4. However, the graph of submetering 3 kept on increasing and it didn't get affected by changing season. But seasonal effects can be seen in the graph of global active power, which shows some periodic fluctuation. Some spikes can be seen in different graphs, which might be due to a certain increase in power consumption due to some special occasion. Now, let's have a look on the graph of global active power in detail. We created the plot for active power for each of the year to look for annual patterns. As evident from the graph, the active power has downward trend towards the summer month and more consumption during winter months. During the month of August, September, the power consumption is at its lowest across years. For more detail, let's have a look at per month analysis of global active power. From this graph, we can see some consistent pattern of power consumption across days. At the same time, we have some days of minimal consumption in the month of February, April, and August. This indicates the home was unoccupied at those times. Here also, we can see the maximum power uses during December and January, that is during the colder months. Now Samir will explain you about various histogram plots.
Thanks, Nishant. Now, proceeding further in the section of data visualization, we analyze few more graphs related to time series data. Now, as we see in this graph that it represents the separate histogram for each of the 8 variables. The active power, reactive power, intensity and all sum metered power are well skewed and down towards small watt hour or kilowatt values. The distribution of the active power to be bimodal means it shows that it has two mean group of distribution. Now, let's have a look at the distribution of the active power across the years. The distribution across the years looks similar. From the graph, it is very evident that it has two peaks, with one peak around 0.3 kilowatt and another one around 1.3 kilowatt. And there is a long tail distribution to higher kilowatt values. Also, we see that for each year the graph shows similar behavior over 4 years, showing that two peaks every year. Considering the next histogram now, we plotted the distribution of the active power for each month of a year. The data distribution for each month seems quite similar with quite a few differences. The peaks are shifted up for a colder months due to the more power consumption due to the more uses of heating devices and down for the warmer months. The graph itself explains the consumptions and how it varies accordingly. A thick and more prominent tail towards larger kilowatt values for the cooler months of December to March is also very evident from the graph. Now, from here on, I would like to invite Anand to explain the presentation further. Thanks.
Thanks, Samir. Let's have a look on that bar graph. The bar graph represents mean of global active power resampled over quarter. As evident from the graph, it is very clear that global active power consumption decreases during the summer months and it shows decreasing trends across years. And the consumption was minimal during the month of August and September. Now, for better visualization, we plotted another graph in which it is easier to observe the variability of mean with changing months or season. This was all about data visualization. Now we will move forward to discuss about data statistics. Statistics is basically a science that involves data collection, data interpretation, and finally data validation. Here we will find several measures of central tendency. This includes mean, median, mode, standard deviation, count, variance, quartiles, mean, and max. In this slide, we can find central tendency of all variables. Especially for hypothesis testing, we need data like mean and variance of population and sample. Now, Yash will explain about hypothesis testing.
Thank you, Anand. Now we will know about hypothesis testing part of our project. Firstly, just for our intro, hypothesis testing is a form of statistical inference that uses data from a sample to draw conclusions about a population parameter or a population probability distribution. Firstly, we have assumed our null hypothesis or H0 that the mean of global active power will remain unchanged, and alternative hypothesis that is denoted by H1 is that the mean of global active power will increase. So we have taken the sample as the data points of year 2010, and since the number of data sets is greater than 30, we will apply Z-test on it. Now we know that Z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. Also, Z statistic follows a normal distribution. Now, here is the formula for Z statistic, where mu naught is null hypothesis, given mean to be tested, sigma is the standard deviation, n is the number of samples, xn bar is mean of samples, Z is tested statistic. Now we have calculated the required values for our dataset, and after applying Z formula, we are getting Z statistic as minus 19.958. And after using Z table, we can say that probability of mean to increase will be close to 1, so we can easily reject H0 or our null hypothesis, and thus the hypothesis testing part completes. And now I thank you all on behalf of my whole group for listening to our presentation. Thanks.